Our next major object-oriented programming topic is something called polymorphism. And polymorphism comes from the words poly and morph, where poly means many and morph means bodies or forms. And the way that this applies in computer science is related to our previous topic, inheritance. So the idea here is that it's possible for an object of one type to be able to act as though it is an object of other types. And you may wonder why that's important. But I'll give you an example right here. We've actually already been using polymorphism in our Pokeyman code, and we just haven't really thought about it too much. If we look at our players, we have a regular player. The object that we create from that player class was called me. Then we have an object CPU that is a computer player type. So remember that Java is a strongly typed language, so that means that variables have to have a type associated with them, whether it's an int or a string, or in this case a player or a computer player. And just as we can't pass, say, a char into a method that requires an integer or requires a string without doing some kind of conversion, the same thing should be true when we're dealing with other types. So what this means is if we take a look, for example, at this take turn method. So on line 24, I'm calling the me player's take turn method. Now, if we look at the take turn method expects you to pass in a player. And that's because when you pass in that player, it is expecting to be able to do certain things with it. Things like to be able to get its name. Things like to be able to pass it in to poke it. And the poke method also expects that it will be given a player. And that's because with that player, it's going to want to be able to set its patience and get its patience. And so if you were to pass in an incorrect type of variable here, it would not be able to call a set patience method or a get patience method because a different type may not have access to these particular methods. So typing is really important. You have to pass in the right kind of variable so that the method knows it can do the right kinds of things. Now, if we think about what we did on our last lesson on inheritance, if we go back to the main method here, let's take a look. I'm actually passing into the takeTurn method the computer's object, CPU. Now, CPU is not a player. It's a computer player. And yet this doesn't cause an error. And so we might wonder, well, if this is a different type than a player, why is it that I'm allowed to pass in a computer player? Well, remember, the reason we need to pass in a player there is so that we have access to things like the poke method, the set patience method, and the get patience method on whatever object it is that we pass in. But a computer player extends the player class. That means that computer player is a player. It's just a slightly different kind of player. It's a player whose take turn method we've changed a little bit. It's a player that has additional methods perhaps, or it might even have additional fields or data members. But the point is that every computer player, because it already extends the basic player class, it's a subclass of the player class, it automatically has access to all of the player's methods. So we can ensure that anything that's a computer player will also have all the same methods available as a player. And since it has access to all of these setters and getters and data members and methods, then what that means is that it's okay to pass it in to the take turn method because take turn expects a player, but CPU can behave as though it's a player because it has all the same methods in addition to any new ones that it might create. So because the computer player inherits all the public members of a player, we would say that a computer player is a player. It's a kind of a player. And so a computer player can behave like a player. It's polymorphic. It can act not only as a computer player, but also as a player. So anywhere where a method requires a player to be passed in, we can pass in a computer player. And that really makes a lot of sense because it would stink if I had to rewrite a take turn class that also accepted a computer player. in addition to a regular player, basically just redo this whole method, but change this to computer player. Or if later on I decided that in addition to a computer player, maybe I wanted an internet player or something that had some other characteristics, if I had to keep rewriting these methods to have different versions for all the different possible classes I might create later, it'd be a real nuisance. So instead what you do is you extend this main class like we did here for the computer player, base it on that computer or on that player class, and now your new class can behave as though it were the same as the original class. One thing that's important to understand is that this does not work the other way around. So I can't pass a player in where a computer player is expected. To demonstrate that, let's add a method to our main class. And this method is simply going to trigger the desperation attack on a computer player to go attack some other player. So what this is going to do is trigger the CPU, the computer player, to take a desperation attack against some other player. So you need to pass in, well, which computer are we going to be panicking, and which player is that computer going to attack? So this method requires a computer player to be passed in, and it requires a player that that computer is going to attack to be passed in. So just to make this a little easier to understand, let's add an additional regular player. And now let's see if we can get one of these players to trigger a desperation attack against the other player. Now, right off the bat, this should make no sense because we know that a player doesn't have a thing called a desperation attack, and that's really the big issue. So if I were to attempt to run the panic computer method and say, well, let's cause player 2 to run a desperation attack against me, you can see that we immediately get an error here. And if we hover over it, the message is that the panic computer method requires a computer player, but what we passed in was actually just a player. And this makes sense because if we go down and look at the method, when we pass in a regular player here, a player doesn't have something called a desperation attack. So it makes it impossible to actually do this with an object that's a player type. So the key thing to understand here is that polymorphism generally doesn't work in two directions. When a class is derived from another class, in our case when our computer player extends the player, what that means is that a computer player is a player. And everywhere where we need a player, we could also use a computer player. But anywhere where a computer player is needed, we must have a computer player or another type of class that might be derived from computer player. But we cannot pass in a superclass where a subclass is expected, because we have exactly this kind of a problem occur. Now luckily Java is smart enough to know that, and it will give us an error if we ever try to do something like that. Okay, so that's polymorphism, and the key thing to remember is that an object created from a subclass can be used instead of an object created from the superclass.